Good afternoon, everyone, and welcome to the second half of the cloud infrastructure track. I'm very, very happy to welcome our second PM keynote this afternoon, Yury Izrailevsky, who's VP of the cloud platform at Netflix. And you should really, sit back and get ready for a fantastic ride, because he's going to tell us how Netflix transformed themselves into a cloud-native company from a company that wasn't really started off with the cloud in mind. So I think that's going to be a great ride. And please welcome Yury, and give me join me in giving me a wave.
All right, well, thank you for the introduction, Vishal. Good afternoon, everyone. Pleasure to be here. Hope you enjoyed lunch. The food was great. So this talk might not be as exciting as lunch, but hey, at least you don't have to wait in line to get in. So, all right, let's get started. As many of you know, Netflix was one of the first companies that decided to move its entire product operations into the cloud a few years ago. It was a lot of really hard work. We had to make some tough decisions along the way. So today I'd like to share some of the key lessons that we learned from that experience. So first off, a little bit of history. Our journey to the cloud began almost 6 years ago, in the summer of 2008, during the Beijing Olympics actually, when we experienced a major database outage, and as a result, for 3 days, we could not ship DVDs to our customers. So this was a very costly and embarrassing outage, but at least it was mitigated by the fact that customers could still view DVDs that they had at hand. So at that time, we were just beginning to experiment with our streaming service, and we quickly realized that a similar kind of streaming outage would be totally devastating for our business. And that's when we decided that we had to move away from vertically scalable single points of failure, like relational databases in the data center, and towards horizontally scalable, highly reliable distributed systems in the cloud. And as we continued with our cloud migration, we had 3 top priorities in mind: scalability, performance, and availability. So let's start by talking about scalability. As you can see from this graph, over the past 5 years, our streaming usage has grown by more than 100 times, to where last quarter we've streamed over 6 billion hours to nearly 50 million customers all over the world. So sustaining that kind of growth would be virtually impossible from the data center, with its long provisioning cycles, and we simply would not be able to rack up hardware fast enough. And it's really the scalability of the cloud that allowed us to add virtually thousands of instances and petabytes of storage in minutes and grow at that kind of pace. And benefits of the scalability of the cloud become even more obvious if you look at our global expansion. For a long time, we were a US-only company, and then in 2010, we launched in Canada and then Latin America, but we're still serving all of our Western Hemisphere customers from a single cloud region in Virginia, in AWS US East. And then 2 years ago, we launched in Europe for the first time. And in order to give our European customers low latency interactive experience, we spun up a second cloud region in Ireland. And then we would keep the 2 regions in sync using Cassandra replication. So if we were to rely on our own data center and spin one up in a different territory, it would take many months. We would need to provision the colo space and get some servers and rack them up, get an operations team going. And it would be a huge upfront investment that we would hope to grow into over a period of time. Well, in the cloud, we were able to get a new cloud region going in a matter of a few days. And we could go with a really small and cheap initial footprint and then expand it as our customer base grew. And as we continue to grow and expand and become a truly global company present in every media market in the world, we can rely on this vast network of global cloud regions so we can reach our customers with great service wherever they happen to be in the world. Now let's talk about performance. So as I talk to my colleagues in various companies that are considering moving into the cloud, I often hear that, sure, cloud is great, scalability, reliability, but it's just way too expensive. We simply cannot afford it. Well, at Netflix, as we moved from the data center into the cloud, our costs actually decreased by 87%. Per streaming session, it costs us 1/8 in the cloud of what it used to cost us in the data center. So what is it about the cloud that makes it so cost effective? And there are two major factors at play here. Number one, it's the economy of scale. Netflix is a pretty big online property. We have tens of thousands of servers. We use terabits of bandwidth, petabytes of storage. But if you think of the total amount of cloud resources consumed by hundreds of thousands of cloud customers out there, we're really a small drop in the bucket. And large cloud vendors like AWS can use huge economies of scale by purchasing hardware more cost effectively and spreading the development and the operation costs across this large customer base so that they can operate a high volume, low margin business and pass those savings back to us as customers. And the second factor is the elasticity. So as I mentioned earlier, it's really the elasticity of the cloud that allows us to add thousands of instances, petabytes of storage within minutes that allows us to sustain that kind of growth in the long run. That's true week after week, month after month, but it's also true throughout the day. If you think about it, Netflix is a very cyclical business. Most of our customers use it in the evening. Our peak happens to be around 7 p.m. in every local market. And hardly anybody uses Netflix at 4 o'clock in the morning. So we can actually rely, using load-based autoscaling, and automatically grow and shrink our production capacity so that we only pay for what we use, and that makes us more efficient throughout the day as well. Now let's talk about availability. Our goal at Netflix is to build world's best streaming product. That requires a lot of things. Great personalization, UI, deep content catalog, supporting lots of devices. But at the end of the day, the product just has to work. So think of your lights coming on when you flip on that switch, or your TV channels coming up when you turn on the cable box. So reliability is really critical. And we've set an aggressive goal of 4 nines of availability, which means that on any given week, we cannot afford to be down for more than 30 seconds at peak traffic. So that's a very aggressive goal indeed. How have we done against that in the past? So this graph tracks 13-week moving average for our weekly streaming availability over the last 3 years. And as you can see, the overall trend is upwards. In fact, we've added more than a full 9 of availability during that time. But this has not been all smooth sailing. In fact, you'll see there's a pretty big drop in the middle there that corresponds to a single outage as a result of the AWS Elastic Load Balancing Service failure in the US cloud region in Virginia that happened on Christmas Eve of 2012. So that was a pretty big outage, but we've learned from it. And as a result, we've re-architected our systems to use cross-regional failover. So if something like this were to happen again, we'd be able to survive it with much less impact. And in fact, there have been a number of outages that happened during that time that we were able to survive pretty well. At the end of the day, the cloud is about building highly reliable services out of fundamentally unreliable but redundant components. And we can and we will use redundancy of the cloud to build highly reliable systems and survive just about any outage that can happen. So as you can see, cloud has given us tremendous benefits in terms of scalability, performance, and availability. But not every cloud configuration offers the same degree of benefits. Arguably, the easiest way to move into the cloud is to just take your data center-based capacity and forklift it into EC2 or whatever other cloud vendor you have. It's the easiest, but you will likely end up moving all of the problems and limitations of the data center over into the cloud. So instead, at Netflix, we decided to go the cloud-native way, basically re-architecting all of our systems, for example, moving to service-oriented architecture, and shifting from relational to NoSQL distributed databases. We've developed a new security model so that now we're using identity and access management, AWS security groups, and the cloud hardware security modules, among other things. We've embraced a new operational model, shifting to DevOps. And we've even had to make changes to our organizational structure so that we operate more effectively in the cloud. So let's talk about some of these in more detail. So back in the data center, all of the different applications and services making up the Netflix streaming app were consolidated within the same Java application called Java Web. So this monolithic application architecture had some advantage. For example, latency was pretty good because all the different components could efficiently talk to each other on the same box. And it was also pretty easy to scale it up because you simply add more Java web servers, and you load balance across all of them. But this monolithic architecture had two major problems associated with it. Well, first of all, reliability was pretty poor, because if there was a failure in one of the components, it was likely to bring down the entire system along with it, because that component was sharing resources with everything else on the same box. And the second problem was poor agility. All of the different development teams that used to contribute to the same application had to tightly coordinate with each other. Everyone had to move in lockstep, and if one of the components was delayed, everyone was held back. Nobody could release. So the best that we could do in this monolithic architecture was to release once every 2 weeks. Now, Netflix is in a very competitive environment, and it's really important for us to succeed as a company to innovate and iterate as quickly as we can. So making changes once every 2 weeks was just not going to cut it for us. We would fail as a business. So in the cloud, we've actually shifted to a distributed service-oriented architecture where we have over 600 different components and services, each running on its own separate cluster in the cloud. And they talk to each other using RESTful interfaces. So right away, this distributed architecture helped us iterate and move much more quickly because development teams could just release on their own schedule. There was no centralized coordination whatsoever. Well, what about reliability? After all, there are still dependencies between those components, and cascading failures are still possible. Well, consider a pretty typical example of a cascading failure that happened a while back, where AWS SimpleDB service had a spike in error rates, and that, as a result, that brought down our instant queue service, and that affected the API layer. And consequently, some of our customers could not stream on their devices. So this is a pretty typical example of a cascading failure affecting 3 components in the cloud. Well, as I've mentioned, we have over 600 components running side by side. And if we depend on the availability of each and every one for the whole system to stay up, then, and let's say the availability of each component is 99%, then the combined availability of the system is 99% to the power of 600, 0.24%. Basically, a system would always be down. Well, my bosses would tell me that we've got to do a little better than that. So somehow we have to design architecture that would survive the failure of one or several components without bringing the whole system down. And there are really 2 strategies that we can employ to do that in the cloud. One is graceful degradation, and the other one is redundancy. So graceful degradation basically means that if one of your dependencies fails, rather than bringing the whole system down, you simply degrade part of your functionality while the rest of the system continues operating as normal. So for example, if the movie personalization service that populates the top 10 recommendations for a customer at Netflix fails, you simply drop that row and you show popular titles instead, while the rest of the system continues operating as if nothing. And of course, redundancy is really critical at all levels. For example, we deploy all of our components across at least 3 different availability zones or cloud data centers in each cloud region, so that if one of them fails, we can continue serving customers from the other 2. And as I've mentioned, we've adopted cross-regional active-active architecture, where in the normal state, our North American customers are served from 2 cloud regions. East Coast customers go to Virginia, and West Coast customers go to Oregon. But if one of those cloud regions fails, we shift the entire customer traffic to the healthy region using the DNS configuration. And just as reliability is important for our runtime system, it's even more critical for the durability of our data. So in the cloud, for example, we're storing all of our data in Cassandra, where each data element is replicated across at least 3 different availability zones in each cloud region. And that helps to ensure our resiliency against hardware failures. And then to protect us against logical failures like software bugs or operator errors, we generate regular snapshots of all of our data into S3 in the same cloud region. And then to protect us against catastrophic failures like natural disasters affecting an entire cloud region, we generate a secondary backup of all of our data in our heterogeneous cloud environment that goes to multiple cloud vendors. So as you can see, we have multiple levels of redundancy to guarantee the availability and the durability of our data. But just designing fault-tolerant systems is not enough. You constantly have to test your ability to survive all sorts of failures. Imagine getting a flat tire. You might have a spare in your trunk, but is it inflated? Do you have the tools to change it? And most importantly, do you remember how to do it right? Well, one way to make sure is once a week you poke a hole in your tire and you go through the drill. And this is exactly the approach that we've used when we developed Chaos Monkey, which is a tool that goes and randomly shoots down production instances just to test our hardware redundancy. And to test our graceful degradation, we have Latency Monkey, which is a tool that randomly injects network latency across components. To test our zone redundancy, we've built Chaos Gorilla that simulates a zone outage. And now we also have Chaos Con that simulates the downtime of an entire cloud region. We also have Security Monkey, Janitor Monkey, Conformity Monkey, Doctor Monkey, the whole Simian army of monkey tools to ensure our resiliency in the cloud. So this Chaos Monkey and the Simian army have been tremendously helpful for Netflix to deal with all sorts of failures in the cloud. And 2 years ago, we've actually open sourced it to the wider community. And there's been a lot of adoption, a lot of contributions back. And in fact, this is just one of over 40 different open source projects that Netflix has made available over the last 2 years. Again, there's been a lot of adoption in the community. Many of you here in the audience or your teams have looked at it and have contributed back. We really appreciate that. You can find more details at netflix.github.com, and I hope that we can continue to collaborate on this project and move it forward together. We all have to gain a lot from it. Now let's talk about operations. So back in the data center, we used to have a centralized operations team, the NOC, that was managing all of our hardware capacity and coordinating bi-weekly releases. As we moved into the cloud, we've shifted towards continuous deployment where each development team is responsible for their own release schedule. Some of the teams make releases once every other week or once a week. Others use continuous deployment where changes go out every day or multiple times a day. And there is no centralized coordination across those teams. And just as we've changed the process, how we make deployments, we've also changed the underlying mechanism. So back in the data center, we used to rely on the rolling upgrade of binary configuration onto running instances. So we would take a node out of the load balancer, we would push the new version out, and then we would put it back in. It used to work OK in small clusters, but as our footprint grew to hundreds, thousands, tens of thousands of instances, it became virtually impossible to maintain all of those clusters consistent. And we would routinely end up with different versions of the same software running within those clusters, causing all sorts of problems. And we used to call this condition versionitis. So as we moved into the cloud, we've shifted to AMI-based deployments, where each time we release a new version of software, we bake a new machine image. And then we spin up a brand new cluster of virtual instances off of that AMI. And that guarantees that all of the nodes in that cluster are 100% consistent. So this cured versionitis, but it also enabled us to do things like red-black deployments, where whenever we do a software release, we push 2 versions of the code out in production, one running the old version of software and the other one running the new one. And then we start to gradually shift the load from old to the new while keeping the old one 100% operational. And if everything goes wrong with the new code, we can instantaneously shift the load back to the old one. Now, this is a very, very powerful technique that can allow us to deal with just about any kind of failure that we can experience during new code pushes. And it's only possible in the cloud where you can, for a short period of time, double your production capacity, and then you can spin it back down after you no longer need it. Now let's talk about some of the organizational changes that we've made as we migrated into the cloud. Back in the data center, we had IT department managing all the budgets, planning things out into the future, and then approving and allocating hardware capacity and other resources to various development projects and to the development teams. And as we moved into the cloud, we've shifted that responsibility directly to the development teams, to where each development team can provision whatever resources they think they need to get their job done. There is no hardware review committees. There is no approval gates. There is no centralization. Everyone moves at their own speed. And of course, visibility is really important. So we invested quite a bit into monitoring and operational tools to make sure that we stay efficient. Back in the data center, we used to rely on coordinated releases by the NOC. As we moved into the cloud, we've disbanded the NOC. And we've shifted the responsibility directly to the development teams that run DevOps and operate releases on their own schedule. Again, there is no centralized approvals or coordination. And we have a small team of site reliability engineers building operational tools and sharing best practices across the organization. Back in the data center, all of our production data used to be stored in a handful of large Oracle databases. And we had a pretty big team of DBAs administering those. As we moved into the cloud, we've denormalized our data model, and we're storing it in about 100 different Cassandra clusters, big and small, administered and managed directly by the development teams. And we have software engineers basically maintaining the data model and operating these Cassandra clusters. And finally, on the data warehousing side, back in the data center, we used to store all of our analytical data in relational databases, Oracle and Teradata. And as we moved into the cloud and our data volumes grew into petabytes, we've migrated all of that data into S3 as a source of truth. And we are processing it using Hadoop, running on top of Amazon's Elastic MapReduce. And we have software engineers building production ETL using Pig, Python, and Java. Whenever you consider a big infrastructure change like moving to the cloud, it always helps to try out on a pilot project. It helps you kick the tires and become familiar with the environment. So why not start with building a jobs page in the cloud first? It's a pretty small project, not a lot of pages, not a lot of complexity. So it's a good way to become familiar with the cloud environment, but it's also symbolically very important because it'll emphasize the need to bring new skill set into the organization, whether you develop it internally or you hire for it externally. So in summary, if I can distill my talk, there are three main lessons that we've learned from our cloud migration. Lesson number one, it's really important to invest in building cloud-native architecture. Even though the easiest way to move into the cloud is to forklift your data center-based systems and drop them into EC2 or whatever other cloud environment you have, it's the least productive way to do that. And to take advantage of the full set of benefits that the cloud environment has to offer, you really need to re-architecture the systems in a cloud-native way using the principles of graceful degradation and redundancy, moving to service-oriented architecture, shifting from relational to NoSQL distributed databases, and denormalizing the data. Lesson number two, it's important to embrace the cloud-native operations model, basically DevOps. For us, it means moving to continuous deployment, being really disciplined about running regular production drills, things like Chaos Monkey and the Simian army, and also moving to AMI-based deployments that allow us to do things like red-black pushes and cure the versionitis. And finally, and perhaps the most importantly, lesson number three, to succeed in the cloud, you really need to evolve your organization in a cloud-native way. So for us at Netflix, that meant migrating the capacity planning and the budgeting responsibility from the IT department and from the finance department directly towards the development teams and allow them to iterate as quickly as possible and bring the innovation forward. And you also have to be focused on bringing new skill set into the organization, whether it's DevOps engineers or engineering talent that's familiar with the technology stack that's native to your new cloud environment, things like Cassandra, Hadoop. At the end of the day, our goal at Netflix is to build world's best streaming product. But to make that possible, we need to solve the problems of scalability, performance, and availability. The same set of challenges that all of you guys are facing within your own companies. Cloud provides us with a set of basic infrastructure components, but it's really up to us to stack them up in the right way. So I hope that we can continue to learn from each other and collaborate on things like the Netflix open source, so that together we can solve all of these tough challenges and build systems that are highly reliable, very efficient, and infinitely scalable. That's it. Thank you.